I'm the chair and executive director of computing and data science at the university. That basically just means that I oversee all of the undergraduate and graduate computing and data science programs, of which there are several now, and we are growing rapidly. But for this webinar tonight, we're going to be talking about our graduate data science program, which is possibly the fastest growing program in the portfolio at the moment. We are so excited about kind of growth in this area, what our students are doing, and how well this program has been received in the marketplace so far. And so I will cover all of that as we go through the presentation this evening. So first off,
Jameson,
yeah,
just really quickly, I see on the screen that you've started screen sharing, but I don't actually see your slide. So I think you may need to select.
Oh,
there it is. Perfect. Sorry for the
interruption.
You
got it. Okay. No worries. All right. So you can see the slide now. How about this next one? All right. Excellent.
Now it's a real thumbs up.
So what the heck is a data scientist? Here is one definition that is pretty similar to a lot of definitions that I come across online. Basically, it's someone who can use some programming skills to wrangle data, and then once you have that data, use some of the tools in the statistician's toolbox to derive some insights from that data. So this really leaves you with this kind of picture of a data scientist. So on the left-hand side, we've got programming that's basically learning how to write some computer code that helps you automate processes, and then statistics on the other hand, which gives you the tools and the expertise to model some of that data that you use the programming to bring in. And so when most people think about a data scientist, they're thinking really this intersection between programming and statistician. However, what a lot of folks miss is just how important context is to the data scientist's day-to-day work. And so managing data. Well, how do you know what data is actually going to be important to model without knowing the context that you're working within? If you're in a sports context, let's say you're trying to model something like, oh gosh, who's going to be the best wide receiver for your football team? Well, you need to know something about the kind of data in that context that might make sense in performing that sort of prediction. Similarly, let's say you're working in healthcare. Well, you need to know, is it number of beds? Is it number of nurses that we have on staff? Is it level of sickness of our patients? What is it about the context that we need some expertise in order to actually do some sort of successful model? Similarly, on the other end, after your model is done, how do you know what's actually going to be important without knowing something about the context, right? Well, is it important that your wide receiver score touchdowns? Well, if you didn't know anything about football, you wouldn't be able to answer that question. Is it important for your patients in a healthcare setting, to live longer? Well, I guess we would probably all know that, even if we aren't doctors or nurses, but there are other types of outcomes in a healthcare setting that we might care about and that we might want to model that you won't understand unless you have a deep understanding of the context within which you are working. This is crucial when it comes to actually presenting those findings at the end as well. So you've got to know what data to gather, to put into your models. You need to know what sorts of things are important to the decision makers that you are creating this model for. And then crucially, you need to be able to take all of that and turn it into something that you can actually present to these decision makers in a language that they can understand. Remember, you're not always presenting to folks who understand programming and statistics. You're often, in fact, most often, presenting your work in a context where the decision makers know very little about the work that went into your project. And so context really, really matters. And so the way that I think about the modern data scientist is really as the intersection of these three circles. So you live right in the middle there. Some of you are going to be better programmers, some of you are going to be better statisticians, some of you are going to be better communicators and experts in a context. All of those are important for the day-to-day work of the modern data scientist. All right, that's what a data scientist is. Now, why the heck would you want to become a data scientist? Well, I mean, I think it's pretty darn cool, but you might not, and you might need to be convinced. So here are some reasons. Number one most promising job according to LinkedIn. Okay, there's a bunch of stuff out there for you to do if you wanted to. It's topped Glassdoor's list of best jobs for the past 3 years. So in other words, the folks who have this job seem to think it's pretty cool. You can make a lot of money. Now, that's not always your starting salary, although we have had several graduates of our program get salaries that are even much higher than that coming out of the program. But remember, this is more like after a few years in to the gig. 50% of the jobs in the top income quartile require some sort of coding skills. So literally, no matter what kind of job you want to go after, the skills in the data scientist toolbox are important for those upper income quartile type jobs. It also helps you get a job. It'll double your job prospects, increase your starting salary, and then there are just a ton of jobs out there. There are actually more open positions in computing and data science than there are filled positions in every other STEM field combined. So just to put this in context, I was looking recently in the Portland area. We've got over 5,000 openings in computing and data science. All of the universities, all of the regional universities combined only graduate around 1,500 students a year. And so there's a major deficit in the demand out there and the number of qualified applicants in the area. And so if you can get into and make it through a program like this, job prospects are pretty darn good. Okay, so how do you data science? Well, according to LinkedIn, so if you're kind of looking at, you just type data scientist into the search bar, and you look at all of the jobs that are out there, and you kind of distill down which skills they most often list as important. You're going to see the programming languages R, which is a statistical programming language, and then Python, which is more of a traditional programming language. You're going to see data engineering, and that means both learning how to program SQL, which is structural query language. It's a standard language for accessing databases, but also within data engineering are things like enterprise data architecture, learning how to construct the systems that hold, organize, and transfer data around an organization. And then third, machine learning, right? So this is the statistical modeling portion of the data science job, where you are taking a data set, you are applying some sort of model to it. So maybe naive Bayes or a decision tree or a logistic regression or a neural net, and then learning about the patterns in that data and deriving some insights from the output. All that's great, but I talk to kind of upper level managers at many of the local companies around town on a regular basis, and without fail, they always tell me that communication is vital in this process as well. So, you know, some programming, R and Python, some data engineering, some machine learning, that's table stakes. You have to know that no matter what. But really what sets you apart in this industry is your ability to take the insights that number one, number two, and number three give you, and then communicate those within the organization that you are operating. Okay, so that's all about data science in general. What do we do? Well, we took all of the stuff that I just talked to you about, that we learned about the industry, and we developed a program that was geared towards that. So our program, 9 classes, 12 months, oriented towards kind of professional development, getting you out there in the marketplace. There are 6 required classes and 3 available electives. Of the required classes, we've got a foundations course, which gets you into, you know, the basics of programming with R, data wrangling, moving data around, fixing missing data, cleaning it up, etc. Some basic modeling like regression. We have a course on data visualization and presentation. So not just how to create pretty graphs and pictures, but also the theory of data visualization. How are you going to make these things impactful and effective in communicating a given idea? Fundamentals of data engineering, this is your SQL course, your enterprise architecture course. And then number 4, data ethics, policy, and human beings. You cannot, in good conscience, send a graduate student out into the world these days without some training in data ethics. Despite that, I think we are the only program that I know of that actually requires this as a core class in their curriculum. We take this stuff pretty seriously, and our students generally do as well. Number 5 and 6, applied machine learning. That's where you're doing all of your statistical modeling, learning about the various different types of models that exist out there and how to use them, when to use them, why to use them. And then finally, number 6, the capstone seminar. I generally teach the capstone. It's during your final summer semester, and it's a whole lot of fun. We bring in lots of industry speakers. We get you prepared for the job market, and we help you work on a portfolio project. Bunch of electives. These are growing every year, but here's a sampling of what we often have on offer for your choice. If you want to specialize in, you know, more of the kind of communication side of things, you can take classes like communicating with data. If you want to specialize more on the programming side, we've got a Python class. We've also got cybersecurity and some other kind of interesting verticals, and it's expanding every year. A typical curriculum, so if you join as a full-time student, that would mean 3 classes a semester for 3 semesters in a row, starting in fall, then spring, and then you finish in the summer. So you can actually complete our program in 12 months. You would start in fall 23 with 3 classes. Typically, these are foundations of data science, data engineering, data visualization, and presentation. And the reason that we offer these in the first semester is because with these 3 courses, you are essentially prepared to do anything that you want in the internship market. So you can get out there. You are dangerous after taking these 3 courses. And many of our students will work or do internships throughout the year in conjunction with their formal academic studies. Spring, you've got a couple of electives plus machine learning, and then over the summer, you're often taking your ethics course, another elective, and then the capstone. And then you graduate in August, and we send you off onto your lovely, well-paying jobs. Another big focus, I told you this was a professionally oriented program. We care about your career, and that starts right at the beginning of the program, even before you get into the program. During orientation, our kind of executive director of the Career Center comes in and works with you and starts talking about all of the resources that are available to you. This is followed up by some standard events that we have throughout the year and other kind of informal one-on-one advising that goes on throughout the year. In the fall, we typically have a major networking event, and this is for current and former students. This year, we're having a major event on October 7th, where we've got 40 some odd students, around 20 different local employers coming in, and 2 keynote speakers. If you join the program, that will be your first major career event in the program. We also have various pizza workshops throughout the semester, so we will buy pizza for the cohort. Various career professionals will come in, give you advice on how to network, how to update your LinkedIn profile, how to actually do job searches that you care about, and that sort of thing. You will then also be asked about kind of your career aspirations during the fall. In the spring, you can expect to meet one-on-one with the career team. They will be doing kind of an audit of where you are in your personal career and what you need to accomplish over the next 6 months or so to get ready for the job market. And then typically we will set aside some time as well in the spring for our career team to come in and present on the current career landscape, both locally and regionally, and then somewhat nationally as well, so you understand what employers are currently looking for. In the summertime, in conjunction with the capstone class, we do informal interviews. We also bring in industry professionals to interview you. I'm helping you with your portfolio development, and I typically bring in somewhere between 10 and 12 industry speakers to come talk to you in the capstone class about what they're looking for. These are great folks to connect with on LinkedIn to talk about your career aspirations. Many of our students have gone on to work with and for these industry speakers after they leave our program. Some recent placements, KPMG, Activision. So that's a video. I'm not much of a video gamer, but I hear Call of Duty is kind of a big thing. So we had one of our students, they're now a data scientist for Call of Duty at Activision. So that's pretty cool. We just sent another student to go work for the San Diego Padres. We've had a lot of students who are interested in sports analytics. This is certainly a growing area for data scientists. Another is working for Nordstrom up in Seattle. Another is an associate machine learning engineer at Pitchbrook, also in Seattle. We've got folks at the state of Oregon, at Daimler Trucks, at Liberty Mutual, Portland Public Schools. Possibly my favorite student of all time is a math teacher at Portland Public Schools, and she's absolutely killing it, upping the school district's commitment to data science in the curriculum there. Yeah, this is just to say there's a vast array of different types of companies that want this kind of talent. And data science is really a very flexible toolkit that you can use in almost any area that you desire. So folks at the state of Oregon are using machine learning models to help place kids into foster care. Other folks working in nonprofits are using data science to track salmon migrations in the Columbia River, right? So it's not just selling shoes for Nike, copyright, whatever I have to say legally. There are plenty of other ways to apply these sorts of skills you know, for political action, for social movements, for government, for environmental change, for natural science, etc. Majority of our students have a job 3 months after graduation. Hillary can correct me if I'm wrong, but I think every single one of our students has a job now that we are about 4 or 5 months out. Average starting salary is always greater than 100K, and it goes up each year. Let's see, details of the program, 36 credits over 3 semesters. So if you come in as a full-time student, and there are part-time options, but if you come in as a full-time student, you can expect to complete the program in 12 months in 3 semesters. So a fall semester, a spring semester, and a summer semester. Tuition is $17,100 per semester, $51,300 total. Mostly evenings in Portland and Salem. We do have a few elective classes that are offered during the day, but all of our core classes will be offered in both Portland and Salem. You get to pick which of these areas is most interesting to you to do your study. Scholarships and financial aid. If you happen to be a Willamette affiliate, you get an automatic 20% tuition discount. That's pretty epic. Federal private loans are available. This is a full-time graduate program. And almost all of our students get some sort of merit scholarship when they apply. Of course, the earlier you apply, the greater your opportunity to take advantage of those merit scholarship dollars. The application process involves a resume, your undergraduate college transcript, an essay, and 2 letters of recommendation. And I should say, the essay and recommendations are really important to us. We care, you know, why you want to do this program. You know, we want to see that you have put in some thought into what you want to get out of it, and how you want to use this career or this set of skills to advance your career. And of course, you know, those recommendation letters matter as well. We want some understanding of your capacity to take on graduate work at the level that it's delivered in this program. No GRE or GMAT required, but we do look at your undergraduate grades. We do request some programming and statistics experience. It's not required, and we have many students who have minimal programming and statistics experience. Often we point folks towards some free online classes to get prepared for the program if they haven't done any of this, or if they haven't done it in a long time. But generally, we start our classes assuming little or no knowledge, but they ramp up really, really quickly. It is grad school after all, and the courses are pretty fast paced. And so if you don't have a lot of programming or statistics experience, we can point you towards the resources. If you want, you can enroll in one of our undergraduate classes to kind of get refreshed on some of this. There are also free Coursera style classes available online that we can point you to help you get prepared. Early application deadline, December 2nd. So remember, if you want the largest share of those merit-based scholarship dollars, apply early so that we know that you're interested, and we know that you're coming. Those merit scholarship dollars do run out as the year goes on. And so definitely get your application in as soon as you feel comfortable. Okay, Hillary, that's it for me. What questions do we have?
Great, thank you, Jameson. So yeah, please put your questions over in the question and answer field. I know I've kind of been like pinging back with some folks. There are some questions that came in about, can you do the program part-time?
Well, absolutely. So most of our students are taking all three classes each semester. However, many students, for various reasons, uh, uh, need to only take one or two classes in a semester, and that's not a problem. We have, I think, 4 or 5 students from, our cohorts who decide ultimately that they want to take or complete the degree over 2 years instead of one. And that often fits with, family life, full-time jobs, right? All of the other sorts of stuff that gets in the way a little bit easier, because certainly 3 classes, 3 nights a week, with a hefty homework load is a lot to carry when you have a full-time job and a family and other things going on in your life.
Yes. So what would you say to this? This guest is proposing 3 years, so one class per term for 3 years. Technically possible to do.
Absolutely possible. We haven't had anyone do that yet, but yeah, you could absolutely take it over 3 years. And for certain folks, that might actually make a lot of sense.
And you get to hang out with 3 different cohorts, which would be fun too.
And you get to come to our cool data science party 3 years in a row.
I know, people will do anything to go to these parties. So Devin asks, what does the evening schedule look like? So Devin, you're right, 5 to 9:50 p.m. So almost 10 p.m., 3 nights
6.
a week, or 6.
Yeah, so it's 6
Oh
to
yeah,
9:50. Yeah.
of course.
So we typically hold classes on Tuesday, Wednesday, Thursday. So 6 to 9:50. There's always a 30-minute break right around 7:30. And often the students and the instructor will, hike up to the food carts, grab dinner together, chit chat, network, hang out, and then come back to class. So it's kind of also a little bit of social time break between the first and second part of class.
Nice. Thank you for bringing that up, Devin. I know Jameson mentioned that many students work while they complete the program or do internships. So, we really kind of built this schedule in order to facilitate that day to day. Let me see. So an anonymous attendee asks, how is work experience or prior internships considered in the application process?
We absolutely look at your application holistically. And so if, for instance, you didn't have any, experience of one type as an undergraduate, but you get that experience as a professional, we're absolutely looking at that and taking that into account. It's also often a good indication of your ability to time manage and deal with all of life's twists and turns, just in general, right? And this is a grad program, it's rigorous, it's demanding, and so evidence that you can take on a challenge and stick with it is important to us in the application process.
Great, thank you. Can you give any examples of capstone projects?
Sure. So let's see. I had there's a couple of really, really fun ones, and then a couple of more serious ones. So one of the more fun ones, I had a student who did a project called Emojilytics, where they looked at analyzing sentiment as it relates to the emojis that folks use when talking about their shoes. And so this person was looking at, analyzing the language, and so positive versus negative sentiment, and how that maps to the emojis that people use when talking about Nike shoes in particular. And so this was a really interesting project because they were able to then match up specific language with specific types of emojis that only applies in the sneaker industry. right? And so it's a very kind of interesting way of getting some context-specific insights, about the marketplace, and kind of an interesting way that you might use your data science techniques to provide value to an organization. We also had a student look at the impact of the Supreme Court's recent overturn of Roe v. Wade on access to reproductive care across the nation. So a much more kind of serious and somber issue, but she put together a gorgeous kind of graphing application where she was mapping kind of access to care. And what this did was it pointed out specific counties where this was going to be much more important to look at. And so focus for philanthropic dollars and other sorts of kind of resources that might be needed. So kind of a silly, emoji related project, and maybe a serious public health related project. So those are two kind of recent examples.
Nice, thank you. So Matthew asks, and I wonder if he's earlier in the decision process, how is this related to the 3+1 undergrad with master's program?
Well, so we do have an accelerated version of this program for Willamette students, for undergraduate Willamette students. And the 3-1 program allows undergraduate Willamette students to complete 3 years as an undergrad and then start taking graduate classes in their 4th year. So as a senior in college, they get to start taking graduate classes. The advantage is that you get to finish 2 degrees in 4 years plus a summer. And if you follow that degree pathway, and I think we have information on that on the website, you get to skip the foundations course. And so the courses that you're required to take as an undergrad lets you place out of one of the 9 courses in the graduate degree.
Nice, thank you. And I hope that answers the question. I know since we're in a webinar mode, we can't see or hear from our attendees. So if any other questions come up, please pop them over in the Q&A. Here's a good one. Are there faculty within the program with specialty experience in health analytics?
Oh man, good question. Yes and yes. So we have some faculty who actually specialize in things like research design in healthcare settings. And this spring, Kristen Gore is going to be doing an elective on survival analysis, which survival analysis is a technique, a statistical technique for kind of measuring the factors that lead to either lengthening or shortening the duration of something. And so this is often used in healthcare settings to measure things like, for instance, cancer survival or all-cause mortality, among other things. It can also be used in other settings like business settings where it's like, hey, how long do we have to wait before that customer actually buys something, right? So it's survival in a sense, right? Like survival of their willingness not to spend money. So it's a generalizable technique, but it is most often used in healthcare settings. She's also an expert on research design problems in kind of genomic applications, which is a really, really cool area where these kinds of techniques can be applied. Our other professors are not as specialized. However, they always bring in healthcare style problems into their classes. And so if you're doing a machine learning class, you might look at something like, hey, what are the factors that predict how many hospital beds we're going to need in a given month, right? So those sorts of things come up on a regular basis.
And we definitely see it in our industry partners too, from
right, yeah.
insurance, to patient care and everywhere in between. So we've made it to the end of the Q&A. I don't have any other pending questions.
Well, thank you for hosting, Hillary. I really appreciate it. And hopefully our guests got something useful out of this. Of course, Hillary and I are at your disposal. Send us emails. We are happy to answer any additional questions that we didn't get to this round.
It's true. So as Jameson mentioned, December 2nd is our first deadline. We are looking forward to being able to turn those applications around. So you'll have an answer from us before the new year. I know on the website, I think they say February 15th. I think we can beat that. So thank you guys so much for joining. Really appreciate it. Please follow up with any questions that may come to mind. This will be available recorded if you need to go back and watch it again. So look out for follow-up from me. All right. Thanks, everyone.